Hello everybody, Mr. Hinnon here for a little Henstitute help session. Actually not a help session, just kind of a sample problems for electric fields, electric potential, electric forces, electric energy, all kinds of crazy stuff. So what I have here is I have a picture that shows some equipotential lines. So these equipotential lines we indicated right here. So I've got 2 volts, 4 volts, 8 volts, 10 volts, and so forth. So the first question wants to know what is the direction of the electric field at point P, and then the next one says what's the direction of the electric field at point Q. So if you remember, electric fields are just going to be perpendicular to the actual equipotential line. So if you have lines that are showing the electric potential, the electric fields are going to be perpendicular to that. So if I was kind of drawing these out, let's draw in red. If I were to draw this right here, I would have to draw an electric field line that would come right along this particular axis, because that would be perpendicular, this would be perpendicular, and it would just keep going and keep going and keep going and just point in that direction. All of these would be perpendicular. So I would say at point P, it would be pointed to the left. And I could even do it at other places. So if basically it starts here, because this seems to be probably the point, kind of in the center of this, where we have, I would say, 0 volts. Okay, so probably in the center. But we could draw any kind of lines. We could have it go in this direction, and as it travels out, each one of these would be perpendicular, 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 so forth. So then over here at Q, we would actually have this pointed in this direction. So I would say at point Q, it would just be pointed toward the right. So nothing too fancy, just trying to remind you that electric field lines are perpendicular to your equipotential lines, or equipotential lines are perpendicular to your electric field lines. The next one says, what is the magnitude of the electric field? I know we're kind of done with electric field. We're kind of dealing with potential or electric potential, but I think this is still a good one to kind of understand that kind of 2 ideas. We know that the electric field is the force per unit charge, and we know that electric potential is the energy per unit charge. So if I kind of think about this from this kind of standpoint, what we kind of realized is that energy is just really kind of a work being done. So I can multiply top and bottom this by distance, and I basically get the energy. So if I think of force times distance, that would be the work being done on something. That would be the same as the energy. So if I do that to the right side, I have to do it to the left side. And then I end up with ED being equal to my voltage. So what this tells me is that the electric field multiplied by the distance over which it's acting would equal the electric potential. Or, easy way to think of this is the electric field can be found by taking the voltage and dividing by the distance. So we did this for the Millikan lab. You took the voltage across the plates and divided by the distance to figure out what the electric field is. So if I'm trying to figure out the magnitude of the electric field at point P, what I really want to know is what is the voltage difference. Really, it'd be a delta V, so it'd be a potential difference is what we call it, over the distance. So the way I would kind of think of this is if this is 0 volt right here, we're trying to figure out what it is over here. What we could do is we need to figure out what this distance is, and we need to figure out what that voltage is. Okay, so kind of looking at this, it looks like 2 is here, 4 is there, 8 is here, and 10 is there. So it looks like we're halfway between 8 and 10. So I would probably say that we're at 9 volts. So I'd say 9 volts there. And then the distance, since they tell me that each one of these is 1 centimeter, then I would just have to kind of measure from here. This looks like it's kind of in the middle of this section. So this is probably from here to here would be 1 centimeter. From here to here would be 2 centimeters. From here to here would be 3 centimeters. So we're going to divide by 3 centimeters. but we don't like centis, so we're going to get rid of that. We're going to move this decimal 1 2 places over. And we'd have 9 over 0.03. Well, 9 over 3 is just going to be a 3 over 0.01 meters, which basically means move this 2 places and add 2 there, and we end up with 300 volts per meter, which is another unit for electric field. Okay, hopefully that makes sense. Same idea of Q over here. We just have to kind of work this out. So maybe from here to, looks like here would be 1 centimeter, and then here would be maybe 2 centimeters, and it looks like maybe that's a little bit less. So it's a little bit harder to kind of figure that one out. But again, this would be our 0 volts. This is 2 volts. Here is 4 volts. So here's 2, here's 4, here's going to be 6 or 8, sorry. And then over here is 10. So kind of following that around. So it looks like, again, we're maybe at the 9 volt range, somewhere between 8 and 10. It's hard to kind of tell because we kind of skipped here. We went from 4 to 8. That's kind of weird. Like this isn't actually 5. This would actually be probably closer to maybe 6. So it's kind of a weird one. But I can figure out that voltage maybe in 9, and then we just have to figure out distance. So maybe this is half a centimeter, 1, 1.5, maybe 2, I don't know, maybe a little bit less. So I'm going to say that this is 9 volts over, and it's not real clear on this one, so we'll just kind of take our guess. Let's say that this is over about 2 centimeters or 0.02 meters. So again, just kind of dividing that out, we should get 450 volts per meter. So it's a little bit higher electric field over there. And it makes sense because if you look at it, our equipotential lines are closer together. So as we draw electric field lines, they would actually be more together, whereas over here, they're going to be more spread out as they're kind of coming out from this thing. That's a little bit of help. I'm going to throw another sample at you in the Google form. I want to see if you can tackle it. Good luck.